All right, so welcome everyone. Good morning, good afternoon, good evening from wherever you're joining us today. Thanks so much for joining this month Meetup, Data Science on AWS Meetup. I think we do have always a good amount of regulars here in those meetups, but if you're new to this, welcome. We do run those sessions every month, and we always have an exciting lineup of guest speakers presenting on topics all around AI, ML, data. And if you wonder why data science on AWS, Chris Fregly and myself, we've been authoring this book here, O'Reilly book, Data Science on AWS. So if you're curious to learn more about all those technologies and how to get started building data science ML projects, have a look at the book. And Chris, you're online this morning too, right?
I am. Yeah, welcome everyone. Thanks for joining us this month. Just a reminder, we will be posting this video later today onto the YouTube channel, posted again here in the chat. And very excited about the speakers today. We've got some super experienced folks on the line in this area, and I'm excited to hear the talks.
All right, and let's actually have a look at the area today. So today we do have a special, I would call it, on the topic of responsible AI, bias detection and model explainability. So super important topics. And I'm excited. As Chris already pointed out, we do have some great speakers here today. First up here in a second is Dr. Nashlie Sephus. She is a tech evangelist at Amazon AI, and she's focusing on fairness and identifying biases in AI technology. So I'm super happy that she's joining us today. And then the second talk around bias detection and model explainability, we'll have a deeper look at Amazon SageMaker Clarify and how you can use it to detect bias and also to run some model explainability. And we do have Hasan Poonawala with us today. He's an AI/ML specialist solution architect at AWS. All right. And with that, I'll hand it over to Nashlie, who will walk us through the topic of responsible AI. And we also do have chat here. So if you have any questions for her, please feel free to put the questions in the chat window. And with that, Nashlie, over to you.
Awesome. Thank you all so much for having me today. I'm going to share my screen. Thank you for that lovely introduction as well. All righty, so let's get started. So as mentioned, I am a tech evangelist in machine learning under AWS AI, where we focus on fairness and mitigating biases in AI technologies. And I do a lot of outreach events like this and educational things to help try to meet people where they are in their understanding of machine learning, and how do you, with any hat that you wear within that development process, of how you can be more fair and move towards what we call responsible AI, which has several different hats that fall under that. And so assuming that most of you all kind of already know what AI is, and at the core of that, it's not really, you know, what you see on TV. I mean, it can be, it's actually moving closer and closer to that. But at its core, it really involves data, and how do you use that data and find patterns in that data in order to find out, you know, to make inferences about things that may come in the future. The same way with meteorology, when we predict whether the weather is coming, if it's going to storm today or not, is using that previous data in order to learn what's going to happen. And if we only study certain pieces of data, then we can only make certain inferences. So in terms of thinking about your AI product or whatever it is that you're developing, you know, how can you ensure that the end product, whomever it's going to be used on, that you're incorporating all of that potential training data in the very beginning conception stage of your product, because it's going to really be a huge driver in terms of playing games. Or I'm a gardener, so I love using apps to understand, you know, what kind of plant is this in my garden, or weed. It may be a weed that came up and I may want to pull it. We all use different voice technologies, et cetera. Autonomous cars, et cetera, are coming, and several, as we've seen over the last 2 years, health-related healthcare related forms of AI applications are emerging everywhere. That's why it's more important now than ever for us to understand, how is it that we're navigating these important aspects of responsible AI and fairness in AI. So what do we actually mean when we say, fairness in AI? So there's actually been a lot of things come up in the news. A lot of people are concerned about, privacy. They're concerned about being discriminated against. For example, San Francisco were one of the first cities to ban face recognition technology in terms of understanding if the technology is truly, able to be used in real life in these real world, what we call mission critical applications. Keep in mind that anytime you're dealing with humans in the loop or humans in your customer base, or in particular, not necessarily our customers, but those who the technology is going to be used on, those are sometimes two different groups of people. Have you thought through all the different ways that this could, stir up commotion or controversy? And then start there and then just work backwards. For example, a gender classifier, is that even something that we should be doing nowadays? A lot of times, if you've traveled, to an airplane, a lot of us have, and you go through that machine where you have to put your hands above your head. The person on the other side of that machine, the TSA agent, they're gonna have to select whether or not you visually appear to be male or female, and that's gonna set off certain flags or alarms after your body is scanned. Well, you and I both know that you can't really, nowadays visually tell if someone, has this gender or that gender. And so maybe there should be a workaround. Maybe this shouldn't even be common practice. So there's certain things that are often already in place that we want to reconsider how we're doing these products. There have been a lot of potential books and literature on this. Definitely recommend checking out these books if you haven't. Weapons of Math Destruction, Algorithms of Oppression. There's actually one called The Ethical Algorithm that two scholars at Amazon that are actually on my team, Aaron Roth and Michael Kearns, wrote as well to help dig deeper into these topics. And then there's certain legislation that have come out around, privacy, fairness, and transparency, and explainability. And we could talk some more about that. But, in terms of the Privacy Act, there has been pretty bipartisan representation of concerns around these issues. And so again, if you think about it, a lot of times these lawmakers and policymakers are making decisions on technology that they, don't really understand how it works. And so it's important a lot of times in my role to educate these people on that and to make sure they have all the information and the facts that they need to understand how to move forward. Actually, in the European Union, I hear we have some people tuning in from all over. They have actually made several advances to move forward towards a Data Privacy Act, and I actually commend these pathways and initiatives because you have to start somewhere, and that is something that we're also working on. We all have to kind of come together in order to understand what these things are, what do they mean, and how do we best overcome them. And so, in terms of just face. Let me just bring up the face recognition example. There are several different ways in terms of face recognition that already cause errors. This is even without considering privacy or responsibility. For example, if someone has on, if you're trying to unlock your phone, we've kind of seen it during the pandemic. If you have a mask on and you didn't train it that way, then your phone may not recognize your face when you're trying to unlock your phone. Similarly to if people are trying to do face ID amongst many faces in a group in a database of faces, if that person originally wore makeup, or maybe that person originally did not wear makeup, or maybe a portion of their face is occluded by sunglasses or facial hair, then all these things make face ID very difficult already. So also, if you layer on top of that biases in the data itself, then this can add, even more issues. And this is actually a pulled from a paper called Fair Face in 20, I think it was 2019 or 2020. They basically did a survey of the breakdown of ethnicity of faces in various commonly used face data sets up until that point. So all the face data sets you see labeled on the x-axis, were pretty commonly used, but as you can see, they were very much so biased towards the white ethnicity. I think in this particular paper, they were showing that they have a data set that you could use that attempted to be more diverse in terms of that ethnicity. All data sets, let me just say this, all data sets have their shortfalls and their shortcomings. It's up to you to decide which data set is more appropriate for your use case and what it is that you're doing. Let me just double check my time here. Okay, a couple minutes. So what I want to do is kind of also introduce this concept of understanding what is your data set consist of, how do you create the best data set for your machine learning and AI model, and not just stopping there. Once you create the data set, you train the model, it's being deployed, but consider this life cycle of the data set itself. This was actually pulled from a paper called Towards Accountability in Data Sets. Margaret Mitchell is the author of this paper, and a crew from her colleagues at Google. And so understanding, and I don't think she's no longer at Google at the moment, but first of all, what are the requirements of your data? You can think of through several questions, like how are you collecting the data? Is it ethically sourced? Are people aware of what they're doing when they contribute their data? Also, you may need to create a very specific type of data set depending on whatever it is that you're doing. And let me take a step back too and say that sometimes it's okay to have a biased system if you're very well aware of those biases. You may have a particular system that you're designing for a very specific demographic and group, and you may intentionally take that data set and bias it in order to really increase that accuracy for that data set. But there are always trade-offs. And so understanding how do you keep up that data set life cycle in terms of the design of that data set, implementing it, the QA of that data set, testing, and then also testing on your model, but also doing maintenance as you go throughout, and have things like model drift, whereas the application of your original model may have shifted over time when the field or the world or the data that it's being used in changes. And so I'll just close with at AWS, we put forth various efforts to understand what can we do to help our users better overcome some of these issues. And one of the things that we talk about often is SageMaker Clarify. And basically, how do we provide tools to help you avoid some of these common pitfalls and consider these best practices with responsible AI? Again, the easiest thing is to start with the data, identifying those imbalances. So this tool helps you do a lot of that, and several other things, and understand what that model drift looks like in practice and not just in theory. And so with that, I will stop because I'm at time, and I will hand it off to the next speaker.
Yeah, thanks so much, Nashlie. And I think we do have time for a few questions as well before we have a closer look into Clarify. So yeah, if you have questions, feel free to post them here in the chat. And there was one question coming in already around a very important topic, saying that the models are basically built based on the data set, right? So, and the models, and you touched on it as well, they learn from the data set. So touching on that, maybe you can elaborate a little bit, what role does data play, and obviously a big one, in mitigating biases in the models? And how can we make sure to have fair data for building products?
Yeah, so the data itself can be, potential pitfalls can be broken down. I think there's about 3 or 4 ways to look at this. So one, do you have a balanced data set? And of course, this is going to be determined by, what your application is, what your end goal is, really looking into yourself and not taking it for face value that someone hands you a data set and they say this is balanced, and you just, take it and roll with it. You want to make sure you're doing your proper due diligence on every data set. We actually do this on our teams all the time. We properly vet. We have a separate team that actually does that. That's all that they do, this is vet data sets and get feedback on whether or not this is appropriate. Two, really coming up with a system that helps you flag mistakes and annotations or labels of that data. We see this, unfortunately, pretty often, even amongst commonly used data sets. So the biases in those annotations, for example, we were to take a step back from human data, and let's look at something a little bit less critical, like if I were to label dresses in the Amazon catalog, there's cute dresses, there's sexy dresses, there's after 5 dresses, there's dresses that you would wear to a more formal event, like prom or something. And so, someone from a different culture may label that same dress a totally different way than you would. And so again, understanding these different dynamics and viewpoints and perspectives, and ensuring that you've thought through all these things. And we at least don't want you to be surprised that you at least have thought through them. It may not all be solvable, but so there's a few different ways to look at it.
Yeah, definitely. And it's no easy task, right? But
Yep.
We just have to keep doing it. Yeah. Are there any best practices or signals that can help to mitigate the bias?
Yes, I think putting together a very robust testing platform and testing framework, and it's easier, like you said, it's easier said than done. Most people would just say, hey, okay, I would just test, I would get my precision recall numbers, but it's more than that. The way that we test, for example, is that we will take the error, pick one particular feature, because ideally you want to test for biases in every single feature that you're releasing. So for example, recognition at AWS, we have several different features. We can analyze the face. We can detect if a face is present. We can tell if someone has on sunglasses or not. Every single feature. So the sunglasses feature, or the gender ID feature, or the facial hair feature, take that one feature out, look at all the error rates of that, and then combine those error rates into different intersections of groups. So there's, for example, male versus female versus other. There may be ethnicity, break it down to ethnicity, or even break it down into age group, and then even combine those attributes, as we call them, the intersections of those. So short hair, darker skin males, how well does their error rates compare to long hair, darker skin males, for example? You can get as deep as you want. The layers can go very far, but just remember, you can't assume that you're not biased in any of those areas if you haven't tested for it.
Yeah. And I mean, there's so many layers to this topic, right? So, and I think there's no single answer to this, but in your opinion, who do you think is in charge of the fairness, right? Is it the lawyers? Is it the scientists? Is it us developers? Is it the end users, politicians? I mean, there's so many parties involved in making sure we're building responsible AI products, right? So given your experience, what do you think is a good approach here?
So absolutely. And, at AWS and Amazon, we have a new leadership principle around responsibility and taking responsibility. So it's absolutely our responsibility. It's also absolutely, government's responsibility to educate themselves on the topics, and we can help with that too. The policymakers, the customers, how do you properly use the product so that you're not misusing it in a way that will cause harm to someone? And then the users, those who the technology is being used on, are they even aware that this technology exists, that this technology is being used on them? So it really is a multifaceted, solution that everyone has to kind of pitch in and do their part.
Got it. Yeah. And maybe another, like a fun question for you. I mean, you have an impressive career, but what did you make you choose a career in machine learning specifically, and how did you end up focusing on bias and ethics?
Yeah, so I knew that, as a consumer and as a user and as a producer of this technology, we've gone through, life being able to, participate in using the product, but it doesn't always work as well. For example, I have a very well lit, I'm actually facing the window, so I have the light is coming in on me. If I were to turn around, it would probably create this silhouette out of my face because of the backlight. And sometimes that affects darker skinned people more than others. I'm also from the South. If you can't tell, I'm trying to, speak is a way that everybody can understand me, but sometimes, devices that recognize voices cannot understand, what I'm saying, or may get the number wrong or whatever. And at a certain point you say, okay, that's just the way it is. But when you continue living through life and you keep experiencing these things, and we all have, examples, at a certain point you say, well, maybe it shouldn't just be like this. Like, shouldn't they have fixed this by now, whoever they are? So also being they, myself being they, I try to do whatever I can personally to, make sure we're putting our best foot forward. And that's what kind of drew me to the area. And then all of the interest in the world that's moved towards this product, towards this solution. I'm just happy to see that we're at this point.
Great. Yeah, and I know I just recently moved to the US, so I'm still trying to figure out all of the different accents here.
Yeah.
It's no easy task, not even for humans sometimes.
Yeah.
All right, Nashlie, thanks so much really for this kind of lightning talk today. Really appreciate you making the time and joining us. I posted your LinkedIn into the chat here as well, folks on the line. If you want to follow Nashlie for more information, great topics, great sessions around the topic of responsible AI, please do so. And yeah, thanks so much, Nashlie, for joining us today.
Yes, thank you all for having me. Please do feel free to reach out. Hope I can help.
Perfect. Thanks so much. All right. And with that, it's my honor to introduce our next speaker, Hasan. Hasan, are you ready?
Yes, I am.
Perfect. Thanks so much. And Hasan will now show us how you can leverage Amazon SageMaker Clarify to run what we touched on to detect bias and also to do model explainability. And with that, Hasan, I'll hand it over to you.
Yes, thanks, Antje. It's great to be on data science on AWS Meetup with you. So thank you for having me here. And good afternoon, good morning, good evening, everybody, wherever you are. I'm going to walk you through SageMaker Clarify and talk you through the technology that we are building in this space. Let me start with sharing my screen here. So I assume you can see my screen now.
Yes, we can see the slide.
Yes, thanks. So yeah, my name is Hasan. I'm an AI ML specialist solutions architect based in London in the UK. And I've been with AWS for 2+ years now. I really enjoy working with customers, breadth of customers, some beginning machine learning use cases on AWS and some advanced practitioners looking at us to help them optimize their workloads. So yeah, today, happy to talk to you about bias detection and explainability. Some of these capabilities available through the SageMaker platform and specifically SageMaker Clarify. So let's begin with a use case, something common that we see in the financial services industry. So for example, you could, in this scenario, I'm looking at a bank or a money lending agency, which essentially uses a system that uses machine learning under the hood to determine whether a particular credit line applicant or a loan applicant should receive that credit line increase or a loan or not. So you can imagine a scenario where a user applies for a credit line increase. The bank system uses a machine learning model under the hood, and that model returns a low credit score for that applicant, and hence the request is denied. Now, in this scenario, the user, of course, is left, or the applicant is left questioning why did it get denied. The owners of this business system at the bank would want to also ensure that this system is working reliably. So they also would like to understand why a particular output was given by the system. And then we talked about the importance of regulators in the previous talk as well. And regulatory agencies would also want to ensure that such systems do not have any form of discriminatory bias against particular groups. So across the board, you have multiple stakeholders who would like to understand explainability or even bias detection here. And that's the use case I want to walk you through in today's demo as well. So Nashlie presented a similar slide that talked about the various life cycle stages in machine learning. And essentially, machine learning practitioners are faced with the challenges of bias detection and explainability across the life cycle. So right from problem formulation or from determining the data set to be used, they may want to look at pre-training bias, for example. And then after they train a model, they may want to look at post-training bias metrics. They may want to look at aggregate or global explanations from the model. And then once that model is deployed in production, they may want to look at local explanations that are being generated from individual inferences to the model. And finally, as the model runs in production, they want to ensure that there's no drift creeping into the system. So essentially, we are looking at tooling that is required across the machine learning lifecycle to address these challenges. So another challenge for machine learning practitioners is the trade-off between choosing for model accuracy versus explainability. Now, on the one hand, linear models, just by their inherent nature, are highly explainable or highly interpretable, but they may not have the kind of accuracy that you would receive from more advanced models. These days, the nonlinear or the deep learning models, transformer architectures, for example. So there's a wide range of model types, and that each of them could have their own explainability capabilities. And so a practitioner has to also decide which model type should they choose based on their business task at hand. There are also, once you decide to pick an explainability technique, there are several techniques that are available out there. So there are model agnostic techniques like kernel SHAP that we will talk about today, and LIME. There are also model specific techniques, maybe for deep learning models. There's integrated gradients. For GBMs, there is tree SHAP, for example. So there are several techniques, and it's not easy for a practitioner to make a choice. And once they make a choice, they need to integrate these models and ensure that they are not error prone. And so there is a reason to have a managed service that can solve some of these challenges. So when you look at the SageMaker platform, and of course in today's talk, we don't have time to walk through the entire SageMaker platform. It essentially provides tooling and capabilities across the machine learning lifecycle in a very modular fashion. So you could bring certain components of the SageMaker platform into your environment, whether it's building, training, or even deploying models. And SageMaker Clarify provides capabilities that integrate well with across the SageMaker platform. So when we talk about bias detection, you could look at, like I mentioned earlier, pre-training bias in the data itself, or post-training bias detection for the model, maybe explainability of the trained model. So looking at global prediction, global explanations for the model, and then explainability of individual inferences as well at prediction runtime. And finally, integrating with SageMaker Model Monitor. Clarify supports monitoring for explainability drift as well as bias drift. So I want to give an example of a pre-training bias metric that is available in the library of Clarify. There are about 19 bias metrics between pre-training and post-training bias metrics. And I'll give a couple of examples here, but I highly encourage all of you to go out there and have a look at the documentation for each of these metrics. Depending on the business task at hand, some of these metrics may be more relevant than others. So this is the most simplest form of bias metric. What we are looking at is class imbalance. So we have two classes in the data. We have identified in this scenario an age group greater than 40 as one class and an age group less than 40 as another. And you can see that one class is imbalanced as compared to the others, 27% of one versus 72% of the other. Now, what you don't see here is what is the use case or machine learning task we are trying to address. And that would really govern whether this bias metric is acceptable or not. And so we leave it up to individual stakeholders to understand these metrics and then take appropriate decision to address them. Now, if we take another pre-training bias metric example, this is DPL, which is difference in positive outcomes. And so what we're looking at here is for a particular set of classes, and here we define the facet or the sensitive group in this scenario is the gender. So we're looking at male and female, and you can again see the class imbalance or the distribution of data between these two classes. But here in this metric, what we're really looking at is what is the proportion of positive outcomes for one class over the other. So on the left, you can see that 31% of the males receive a positive outcome, whereas 11% of the females receive a positive outcome. So can we use this bias metric to understand whether the data needs certain improvements or certain mitigation strategies before model training? So these were two examples of bias metrics. Like I said, in the demo, we'll show how we produce a range of bias metrics, and I encourage you to investigate them for further understanding. So now moving on to explainability. With SageMaker Clarify supports kernel SHAP under the hood, and the reason we chose kernel SHAP is because it is model agnostic. It also has some really good properties that we will shortly describe here. And so model agnostic capabilities led us to use kernel SHAP in SageMaker Clarify, and SageMaker Clarify provides efficient and improved implementation of kernel SHAP under the hood. So first, let's look at an intuition of what is SHAP. And SHAP gets its intuition from Shapley values in game theory. And so you can imagine a scenario where multiple players are participating in a game and receiving a particular payoff. So in this scenario, there are three players, P1, P2, and P3. And we are looking at different combinations of these players as well as their associated payoff. So if you look at P1, P1 received a payoff of just 25 and P2 received 100. So you could think that maybe P2 is 4 times more than P1. But then when you look at P1 and P2 combined together, you see even higher payoff of 550. Now, I want to acknowledge here that P1, P2 is not the same as P1 plus P2. And so there is a fair amount of math under the hood that I'm not showing here to calculate the Shapley values, which would determine the appropriate contribution by each player in this scenario. And so the table below shows the contribution of each player. And if you take the same intuition to machine learning, the players become the features of the model. And so you can have different kinds of features in a model. In this case, on your screen, you're seeing relationship, age, education, and others. And the Shapley value is essentially the Shapley value and the model predictions are the payoff that you receive from the game. And so we are trying to look at feature attributions, which would be the SHAP values computed by the library. And SHAP here is an approximation of Shapley, because in the previous scenario, there were just 3 players and we had 2 raised to 3, 8 possible combinations of these players. And you can imagine if you have hundreds or even thousands of features, it slowly becomes a computational hard problem to solve. And so you need some form of approximation. And that is what SHAP provides under the hood. So I hope that was useful. Now, quickly moving over to the architecture of SageMaker Clarify. This is a simplified architecture to show the main components that participate in a SageMaker Clarify job. So you have your data that resides in an S3 bucket. It could be the pre-training data that you want to use to train a model on. And then you have the model itself. So you could bring your own model. It need not be a model that is trained on SageMaker. You bring another model, you massage it to work with SageMaker, and you provide these two as input to the Clarify processing job. The processing job under the hood launches a model endpoint. This is an ephemeral endpoint just for running inferences against the various sampling processes that are run for computing SHAP values, as well as if you specify more than one instance for the compute of the SHAP approximations, Clarify uses a Spark cluster under the hood. So for multiple instances, you have a Spark cluster that talks to these model endpoint to compute the approximations for SHAP. And once the job completes, both the Spark cluster as well as the endpoint are shut down and removed from the system. So the output is bias metrics and feature importance that we will look at in today's demo, as well as you can look at several visualizations that are produced in Studio along with a report as well. And you could also use some of this outputs to generate alarms for further monitoring purposes. So in today's demo, I want to walk you through a few things. First, with a tabular data set, we will look at the credit risk prediction problem that I introduced in the beginning of the talk. So that's tabular data. You want to look at both explainability and bias detection with that particular use case. Then we will look at an NLP use case with text data, and we'll look at sentiment classification. We'll also look at some of the advances in computer vision, so with object detection, an example with that. And finally, I'll leave you with an end-to-end SageMaker project template that essentially comes with both model monitoring as well as Clarify capabilities. So going back to the, this is demo 1, going back to the original problem that we began with. You have a user requesting a credit line increase. There is a model under the hood that is returning a response to the user. And we want to ensure that such a model is explainable to various stakeholders. So how would an opaque model look like? In this scenario, there are multiple features. For example, here I've just shown 4 features for illustration purposes. Maybe the checking account status of the user, the purpose of the loan, the employment duration of the individual, and several other features. Now, these features are input to the model, and the model returns a probability score of less than 50%, in this case 7%, and the application is rejected. That's an opaque model, which we need not understand why it made a particular decision. On the other hand, a model with explanations would not only give us the output of 7%, but would also compare that output with a good credit baseline of other individuals who received a positive outcome. So typically, SHAP is a contrastive algorithm. You want to contrast a bad credit prediction against good credit predictions. So in this scenario, we want to see what particular features or input of this particular applicant caused the model to go down from the baseline, which was 78%, go all the way down to 7%. So in this scenario, what is orange in color are the features that are negatively impacting the final outcome for this user. And you can see the fact that the account status is no checking account, and some other features are contributing to pushing the score from the baseline to 7%. So what do we want to do with this demo, and how does it work? We take an open source data set, the South German credit data set, which has several demographic and financial and other information of users, and build a model with SageMaker, or bring your own model. And that model returns a credit risk score of 0 or 1. Now we want to take that model to clarify and produce reports, as well as explainability reports, as well as a bias metrics that give us more information with regards to the model itself. So I'm going to switch over to SageMaker Studio. And I'm assuming you can still see my screen. This is SageMaker Studio. There are several components of the SageMaker platform that are visualized within Studio. Today, we will be looking at the experiments and trials and the model registry as well. So this is a notebook, a SageMaker Studio notebook, where I have run the example. And before I dive into the details of the example, I would like to show you what the output would look like. So we have a credit data set with good and bad credit labeled. We are training a model, we are performing feature engineering, training a model, and then preparing a model to be used with the clarify job. Now, this model could be your own model that is trained outside the SageMaker platform, like I mentioned earlier. So yeah, feel free to look at this end-to-end code example that even shows training on SageMaker, as well as deployment on SageMaker. But I'm going to skip that part and really assume that there is a model that is producing predictions for a given data set, and we want to use it within SageMaker Clarify. So before I show you some of the internal functioning, I want to show you the reports that are generated by SageMaker Clarify. Now, what you're looking at here is a PDF report generated by the explainability job, which is showing us global explanations for the top 10 features in the model. So across the model, across the entire data set, we are looking at which were the top 10 features with highest feature attribution that contributed to the model outcomes. And so here you can see status, amount, duration, and others were such features. And this kind of report can then be presented to various stakeholders, maybe business stakeholders, to help them understand how the model is functioning at an aggregate basis. Now, another popular technique is also to look at local SHAP values. And so that's another chart that is generated by the report. You can not only look at the contributions for each individual prediction or each individual entry in the data set. And red would signify low values of the feature, and blue would signify high values for that particular feature. And we could then see that their contribution to respective SHAP values. So this is for a more advanced stakeholder who wants to look at additional details beyond the aggregate chart. Now, Clarify also supports producing partial dependence plots. Partial dependency plots were the more common way earlier when more advanced techniques did not exist, where you're essentially looking at partial dependencies for specific features and their respective model predictions. So we are looking at just one feature at one time. And so here we have plotted partial dependency plots for the top 10 features that were identified by SHAP in this report. And so you could then look at how did the status feature value really at an average behave against model predictions for different feature values that it could take. Or maybe the amount of the loan, how does the amount of the loan really impact model predictions? So it's important to note here, we are just looking at a specific single feature against the model predictions, whereas something like SHAP considers the combinations of features that come together. So that's the explanation report. And then we have a report that Clarifai also produces, which is the bias metrics. In this scenario, you're looking at the same class imbalance chart that I showed earlier. That's one of the bias metric. And so you're looking at in this case, for the sensitive attribute of age, what is the percentage of population greater than 40 years of age and less than 40. So there are several other bias metrics as well that are produced by Clarifai, and they are described in a tabular format in the report. And then you have post-training bias metrics, where now you're looking at the model prediction as well, and the potential model bias as in this scenario. And so you're looking at things like false negatives and true positives, and computing the bias metrics for each of them as well. So I'm not going into the details of each bias metric, but like I mentioned earlier, do have a look at the documentation to understand them better. So now that we looked at the reports, these reports are also produced in SageMaker Studio UI under experiments and trials. So if you click here, it really opens up into the trial component tab. And so you can look at the same aggregate explanations of different features within SageMaker Studio as well. And then you have access to various resources for further reading. Similarly, the bias detection job also produces a bias report in SageMaker Studio, and you can see both chart visualizations as well as tabular visualizations of the various bias metrics that we talked about. So in today's explanations, we talked about class imbalance, and we talked about DPL, difference in positive proportions and labels. But like I said, there are several other metrics as well. So now let's get back to the code example where we have taken this model and we are passing it to Clarifai. So how does it work under the hood? So I'm getting to the part where we already have a model that is maybe returning probability scores for good and bad credit risk. And so you can see this model is already returning predictions. So how does SageMaker Clarifai work? Well, one of the prerequisites is you need a model that can be deployed to an endpoint. You need the input data set, and finally, you need a SHAP baseline. Now, a baseline, as I mentioned earlier, SHAP is contrastive, so you want to be able to compare a certain set of, for example, bad credit predictions against a baseline of maybe good credit predictions. And so a baseline is something that you input to SHAP and you input to Clarifai. And in this scenario, it could just be a simple average of your data set, or for categorical variables, we are using the mode statistic. And so you define the baseline and make sure that the baseline represents the class that you want to contrast against. So in this scenario, the baseline class is producing a high probability score of 78%. And so it's a nice baseline to compare the bad credit predictions against. What are the other inputs to clarify? You need to provide a SHAP config that specifies the baseline, the number of samples, the aggregation method, and then a PDP config if you want partial dependency plots, the data config to specify the input data set, and finally the model config to specify the model that has now been brought into SageMaker. So once you have all of that, you can then run an explainability job. And once that job completes, you can see the reports like the one I showed a couple of minutes earlier. You can also review the output data in S3. So if I open it up here, you can go to S3 and see the reports that are generated, the report PDF, the HTML, as well as the output values from the SHAP job. So here we can see two CSV files. One of them is the baseline. The other one is the individual SHAP values for individual explanations from this particular job. So like I mentioned earlier, you can download the report from S3, and you can also see it in SageMaker Studio. So now let's move on to what the bias detection job looks like. Or before that, we could look at an example of individual predictions and their explanations. So what I've done here is I've filtered the data for bad credit predictions only, which means that I want to look at individual explainability for certain specific records that received a negative outcome. And I want to then compare them with SHAP and look at them against the baseline. So I filtered the data, and then I'm using the SHAP library to create some plots. You could use Matplotlib or any other libraries to create similar plots. And so what are we looking at here? We're looking at something similar to what we saw in the slide deck earlier, which is compared to the baseline, which is a positive value, what are the top features that push the prediction towards a bad credit prediction? And since SHAP uses for classification problems provides the output before the logistic link function, essentially if the value is greater than 0, the probability is greater than 0.5, and if the value is less than 0, the probability is less than 0.5 and potentially a bad credit prediction. So as you can see here, the baseline is a positive value, but certain features in the customer data set have pushed the prediction towards the negative value, which then produces a low probability score below the threshold cutoff of 0.5. So just like how we could look at global explanations, you can look at individual explanations of a particular user input. So that's individual predictions. And then I just want to highlight that you can also create a bias job, just like we created explainability job, where you provide the bias data config, the bias config, the model config, as well as a predictions config to specify the type of predictions. So we already looked at the reports that are generated from this example. So I want to move on to an example for NLP and look at explainability with text data. So in this scenario, we are looking at individual explanations from the model, and This is an example of sentiment classification use case where we have a fashion data set and we have text data, which is essentially reviews by a particular customer. And we have the predicted label that tells us whether it's a positive sentiment or a negative sentiment. Now, what we want to look at is after training a model, and in this scenario, it's a Hugging Face model that is trained with SageMaker. After training such a model, we want to understand what were the key important words or sentences or paragraphs that contributed to the model outcome. So in this scenario, we're looking at sentence level granularity, and the darker the green color, the more important this particular sentence is to contribute towards a positive sentiment score. And the darker red color is contributing or is pushing the prediction down towards a negative sentiment. So this is the kind of visualizations and outputs from kernel SHAP and SageMaker Clarify that can produce explainability for text classification use cases like this one. And I'm running out of time, so I'm going to quickly move over to computer vision use case, where this is early studies of how we could bring explainability to computer vision as well. And in this scenario, you can look at this is an object detection problem. The model is predicting that the animal in this picture is an elephant, but we are trying to identify what are the key segments within that image that contributed the most towards the prediction of the elephant class. And so the darker the blue color, the more the contribution towards the outcome, and vice versa for the red color. And so this is early work to showcase how you could use SHAP and Clarify for computer vision use cases as well. And we're really interested to hear from customers and from you all, what kind of use cases do you have? So I want to end with just mentioning that SageMaker projects provides you end-to-end MLOps templates that you could provision from the Create Project tab. So if you select a project template that includes model building, training, deployment, and model monitoring, what you end up with is a set of repositories for model building, deployment, and monitoring, as well as pipelines to run these with some default example, as well as a model group that you can then use to update your model. So here we are looking at a pipeline that has run. It's an end-to-end pipeline, and it has a data bias check step. It has a model explainability check step. And these are the capabilities that you can then use to monitor the model for a drift in the future as well. So with that, I realize that we're kind of reaching the top of the hour. So I want to conclude my presentation, but yeah, happy to take questions. Also want to highlight that we have a couple of customer blogs that we will share in our resources as well.
Perfect. Thanks so much, Hasan. Yeah. Perfect landing here on top of the hour. We had a few questions here in the chat, which I tried to answer along the way. Some questions around SHAP and the color coding. I think that I answered and you touched on it throughout the presentation as well. I know it's a little bit confusing if you're looking at that plot for the first time, like what does this color coding really mean? So it's the high and low values actually of that particular feature. And then you have the density plotted in, I think it's a bee swarm plot that's called, right? We had another question. Let me see here. Is the baseline for the SHAP model derived for the whole data set or individual data points?
You could have multiple baselines for your explainability job, but essentially is for an aggregate data set. So it could be the entire data set, or you could generate different baselines for different types of explainability that you're looking for. But the short answer is you're going to compute a baseline on a large data set.
Great. Yeah. And then we had another question touching on which explainability tools are better suited for neural networks. As we know, the deeper the models, the more difficult it gets to explain them. So is there any recommendation from your experience, which tools to use and which tools are maybe less likely to work good with neural networks?
Yeah, unfortunately, there's no winner at the moment. There are several tooling that are coming up for different types of models, and we are continuously investigating these models and seeing whether, or these techniques, and seeing whether they can be integrated with the platform. But there's, for example, integrated gradients. That is a gradient-based technique for deep learning models. There have also been some techniques which are based on attention-based methods. And there is a bit of discussion in the academic world whether these techniques are producing robust results or not. So no winner in the space of deep learning techniques yet, but kernel SHAP is definitely one way that you could investigate deep learning models as well.
Yeah, and if you actually check out SHAP, SHAP already comes with support for natural language models, right? For example, the popular Hugging Face transformers type of models. And I think they also invested in kind of integrating a lot what you just mentioned, Hasan. So they have something called Deep Explainer for TensorFlow Keras models that builds on Deep SHAP and Deep Lift, for example. And also what you called out, the integrated gradients. They do have Gradient Explainer that runs across TensorFlow, Keras, and PyTorch models. So there's a lot of support for neural networks also built in or coming with SHAP and kernel explainer as well here, kernel SHAP. Mm-hmm. All right, could you quickly just help us differentiate between local and global SHAP again? That always comes up and confuses people, and when to use which.
Yeah, sure. So when you're looking at local explanations, you're looking at specific predictions from the system, and you're trying to understand whether that particular prediction was reliable, whether the explanation for that individual example makes sense. And when you're looking at global explanations, you're looking at it at an aggregate fashion. So you're looking at it, trying to vet a model holistically and trying to ensure that that model performs well across the entire data set. So yeah, aggregate versus individual, global explanations and local explanation. Okay,
great, yeah. And if you have maybe the GitHub link handy from the examples, and maybe put that in the chat too for everyone. So if folks want to maybe play around with the GitHub repo here too. And in the meantime, for everyone, I'm going to plug quickly our webinar next month. So in June 20th, we do have our next meetup session. And we're going to have another round of exciting speakers. We do have someone joining us from the Amazon Alexa AI team to talk about optimizing large-scale distributed training jobs using NVIDIA GPU, DeepSpeed Zero, and Kubernetes on AWS. And we also have, again, a community speaker. So we do have Alejandro Herrera joining us from Modin. So if you're familiar with it, Modin is a very popular framework to help speed up your pandas workflows. And we also gonna have an exciting demo and gonna learn more about that in our next meetup. And I see Hasan posted the link here to the GitHub code as well, if you want to play around with SageMaker, clarify a little bit more. All right, and with that, I think, don't see any more questions here coming up. Thanks so much, everyone, for joining us again, and hopefully see you again Let me just, yeah, repost that GitHub link. I see, Hasan, you posted to panelists.
Yeah, and so quick note also, next month we'll have probably 2 or 3 Ray talks. So Modin is Pandas on Ray. And some of you might be familiar, Ray has been used in the reinforcement learning area, but just now we're starting to see Ray being used in the data processing, data transformation, and data pipeline loading for machine learning training and stuff. So we'll have probably, me and Antje have been working on a few demos we'll be doing internally here at like AWS later this week, and then we're going to bring those to you next month as well too. So we'll talk about Ray Serve and Ray Train and Ray data sets, and also how to use Pandas on Ray. So thanks everyone.
Yeah, thanks everyone. I just posted the link here. See you next month. Bye-bye.
Thanks, Kevin.